It's just a theory. Survival of the strongest. It's all a random accident. We hear these phrases constantly when people talk about biological evolution. Yet within the scientific community, the consensus is absolute. Evolutionary biology is the structural foundation of modern life sciences. We have millions of physical specimens, like this fossilized dinosaur skeleton embedded in rock, perfectly aligned with deep genetic sequencing across thousands of species. The reason for this massive public disconnect isn't a lack of evidence. The confusion comes down to a failure of language. Everyday English words have hijacked precise biological concepts. To understand how life on Earth actually works, we need to throw out our everyday definitions of 4 specific words. The first word is theory. In casual conversation, a theory is a hunch. If you have a theory about who stole your lunch, you're making a guess. In science, the word operates differently. We observe facts, like the change in genetic frequencies. A scientific theory is the rigorously tested framework that explains how and why those facts occur. The theory of evolution sits alongside the theory of gravity or the germ theory of disease. We don't doubt that apples fall or that bacteria make us sick, but we use theories to explain the mechanics of those realities. Dismissing evolution as an unproven guess completely misrepresents the highest level of certainty the scientific method can achieve. The second word is fitness. We hear survival of the fittest and picture an apocalyptic cage match where only the most aggressive, physically imposing predators survive. Biological fitness has nothing to do with bench pressing. It is exclusively a measure of reproductive success. It's about how effectively an organism can pass its genes into the next generation. Sometimes the fittest organism is a small mouse hiding from predators, or a primate building deep networks of cooperation to share food. Nature doesn't care about brute strength. It acts as a pragmatic judge, rewarding whatever traits successfully keep a lineage alive in a specific environment. The third word is random. Critics often argue that the complexity of life couldn't possibly be a random accident, like a tornado sweeping through a junkyard and assembling a 747. They are half right. The first step of evolution, genetic mutation and variation, is an inherently random process. DNA makes copying errors. But the second step is natural selection. The environment acts as a brutal, highly specific filter. Only the variations that help an organism survive make it through. This filtering mechanism operates continuously. It relentlessly disposes of failures and compounds successes. Evolution is the exact opposite of blind chance. It is a highly rigorous, non-random sorting process that simply uses random genetic mutations as its raw material. The final word is progress. We like to imagine evolution as a ladder, climbing toward a state of perfection, with humanity sitting proudly at the absolute top. This is what leads to the classic, flawed question: if humans evolved from monkeys, why are there still monkeys? That question assumes life climbs a single ladder. Instead, this diagram shows life as a branching tree. Humans didn't evolve from modern monkeys. We share a distant common ancestor, long before our paths split in different directions. Evolution has no end goal and isn't aiming for complexity. A bacterium is just as evolved for its environment as a human. The concepts of higher or lower organisms are purely biological illusions. Once the confusing vocabulary falls away, evolution stands revealed as a mathematical inevitability. Whenever a population possesses variation, heredity, and limited resources, these mechanics take over. These processes are unfolding in the immediate present, directly impacting human health and our global food supply. Look at this photo of active spraying equipment. We are in an ongoing ecological war with pesticide-resistant insects that rapidly adapt to our interventions. Understanding these evolutionary mechanisms is a critical public health imperative. We rely on them to battle crises like the rise of antibiotic-resistant bacteria. By abandoning our ego and redefining our vocabulary, we realized humanity is not the winner of an evolutionary race. We are simply one leaf on an ancient, continuously growing tree of life.